Yes. Good afternoon, everyone, and I welcome you all to this class on inverse Z transforms. We'll solve numerical problems on inverse Z transforms, and if time permits, we are going to deal with unilateral Z transforms, and we are going to solve few problems related to unilateral Z transforms also. Okay. So meanwhile, as we proceed with the Z transforms module, we covered the Z transforms of useful signals, useful sequences, and we had left-handed sequence, right-handed sequence, and double-sided sequence, and we understood some properties which are related to Z transforms, where it can be used, and so on. So to proceed today's class, and we had already solved quite a number of problems related to inverse Z transforms, and let us continue with today's class. We will be dealing with again the Z transforms. Okay. So with this note, let me share my screen. Yeah. Okay. So the title, let me write it as inverse Z transform, inverse Z transform by partial fraction method. By partial fraction method. By partial fraction method. Okay. So this one, what we are dealing with, find the inverse Z transform. Find the inverse Z transform of the x of z, that is z power 4 plus z squared divided by z minus 1 by 2 into z minus by 4. It's ROC 3. So 1 by 2 is less than one problem x of z here. So this is the it is the zeros. What does the denominator indicate? It is the poles. I hope it is visible to each and every one. So I have x of z. So this is represented in terms of the partial fraction. Okay, we have to solve it by partial fraction method, and its representation is done in a fraction manner. Okay, so its representation is done in a fraction manner. So now how to solve this given x of z through partial fraction method is, I told you earlier, x of z by z, that would be equal to, so I have taken z power 4 plus z squared divided by z minus 1 by 2 into z minus 1 by 4. That would be equal to, let me take z as a common one, z power 3 plus z divided by z minus 1 by 2 into z minus 1 by 4. Okay, so yeah, let me erase this right now. I just wanted to represent. So I have taken z here. So now x of z divided by z, that would be equal to z cube plus z. Okay, z cube plus z divided by z minus 1 by 2 into z minus 1 by 4. Okay, so now what do you mean here? Is it x of z a rational one? I'm asking you, anyone can answer. Is x of z rational? Is it a proper fraction? Anyone can answer. Is x of z by z this one? Is it a proper fraction? Yes. Is anyone there?
No, sir.
Yeah. Okay. Why you generally call it to be not a rational one, nor a proper fraction? Any reason? I told you, is it a proper fraction or not? Yes, the answer is no. Okay. Now, why? Yeah, I want you to answer, because if it is not an interactive session, then how will I come to know that whatever I teach, you are able to listen or you are able to understand it properly? Can you let me know? Okay. So why it is generally not called as a proper function? Okay. So the power of numerator is greater than the power of the denominator there. So whatever the problem that we had solved, it was vice versa, isn't it? So to obtain the given fraction, okay. So what we have to do, we have to obtain a proper fraction. Okay. So we have to obtain a proper function or a fraction. So x of z is to be made rational first. Okay. So now what I'm going to deal here is, so it is z cube plus z divided by z into z, z squared, minus z into minus 1 by 4 z minus 1 by 2 z plus 1 by 8. Okay. So now how I can represent the other one, z cube plus z divided by z squared plus 1 by 8. So minus 1 by 4z minus 1 by 2z. So what it will be? So minus 0.75z. Okay. So 0.25 plus 0.5. Okay. With a minus sign outside, I can write it as 0.75z. So at the end, you are left out with z cube plus z divided by z squared minus 0.75z minus 1 by 8. Okay. So you have to see to it that you are going to take it in a proper fraction method. Okay. So you have to take it in the proper fraction method, and then only you will come to know that this system, whatever that we have, whatever that we get, so that can be resolved into the partial fraction method then. So how you are going to do it?
So it
Yes,
is
how you
plus
are,
1 by 8.
yeah. Yes, plus 1 by 8. Yes, sir. Correct, sir. Yeah. So now can you let me know how we are going to resolve this? Yes, can anyone let me know how we are going to resolve that? Yeah. So you can perform the long division method. Okay. Perform the long division method. Okay. So in order to get the function, whatever that is required in the rational function or the proper function, you have to do the long division method there, right? So in order to do the long division method, again, go for the conventional division method, what we have understood in our lower classes, plus 0.125. Okay. So take it. Yes. So we have z cube plus z, isn't it? Yeah. So can anyone do it now? So z, yeah, long division method. What needs to be multiplied?
Z.
Yes, exactly. So minus 0.75 z squared. Okay. So this is, let me erase it here. Cube minus 0 into z squared, okay, plus 0 into z squared, or plus or minus whatever it is, minus the function plus, yeah, 1 minute, plus 1 into z plus 0. Okay. So now I have multiplied it with z. Okay. So what is the left out one here? So I have z cube plus 0 into z squared plus z plus 0. So z into z, z cube minus 0.75 z squared plus 1.125 z. Okay. So next you have again 0. That is not having any effect there. So let me change the sign here. exactly, yes. So minus and minus get cancelled. So what we have here, so it is, yeah, 0.75 z squared. Okay, so next, what do I have here? 1 minus 1 by 8. Okay, 1 minus 1 by 8, I think I have 7 by 8 z plus, yeah, plus 1. Okay, plus 7 by 8. I want the session to be interactive, students. Okay, so it is better that you create an interactive session here. Now, what needs to be done next? Okay, what needs to be done next? So z squared is here, and here you have 0.75 z squared. Okay, so what needs to be done?
0.75 into.
Yes, so that is 0.75. Okay, z plus 0.75. If you observe here, so z power 1 was there. So here z power 0. So as you see that the power of z is keep on decreasing, and we are nearing to the equation that we are needed of. Okay, so now what I can do here is 0.75. Okay, 0.75 z squared. Okay, 0.75 into 0.75 minus 0.75 the whole square into z. Okay, next 0.125 plus 0.75, 0.125 into 0.75. Okay, so what do I do here? Next I change the sign. So this is plus and this is again minus. Okay, so this is again minus there. Okay, so these two terms get cancelled over here. So what I am going to left out with? I am going to left out with 7 by 8 plus, what is 0.75 whole squared?
0.5652.
Yeah, 0.5652. Exactly. Good. So 0.5652 Z. Okay. So what is this one? Minus 0.125 into 0.75. The answer, please. 0.125, 1 by 8 into 3 by 1 by 8.
Sir, 1.4375, sir, that. 7 by
This
8,
one?
Sir,
7 by 8 plus.
0.5652 plus 7 by 8.
Yes. It is
Sir,
minus here.
sir, not
Sir,
here,
not
sir,
that,
in the
sir.
first term.
Yeah.
So that is only 0.75 whole square.
0.75 whole squared plus 7 by 8. How much it is?
Total
1.4375.
1.4404.
Okay. 1.4375
4375.
Z. Correct. Is it right? Okay. Yes. Next one. So this is plus here. Plus I'm changing the sign here. Yes. Minus. Minus 0.125 into 0.75.
0.09375.
0.09375. Very good. Okay, so now I got this expression. Okay, so I cannot simplify it further. So what do I do next? The expression whatever I have got here, okay, so I need to express it in the format there. So this expression is performed by the long division method. So z cube plus z divided by z squared minus 0.75 z plus 0.125, that would be equal to, so how it has been resolved? So z plus 0.75. Okay, this is z power 0. I'm sorry, this is z power 0, or else I can just erase this z plus 0.75. Okay, so that is z plus 3 by 4. 0.75 can be written as 3 by 4 plus, what is the function over there? I'm sorry, here. Yeah, what is the function over here? I have 1.4375z minus 0.09375. Okay. Yeah. Let me go here. Just a moment. 1.4375 minus point, how much it is? Minus 0.09375 minus 0.09375. Okay, dividing it by this denominator here. So because once you multiply it with the terms over here, so you will be getting the same expression which is there on the left hand side. Okay, so that's the reason.
Sir,
Yeah.
1.4375 Z, sir.
Okay, good observation. Yes. So z plus 3 by 4 plus 1.435. Okay, so see to it that you are going to keep it in fractions, it is okay, or if you keep it in decimals, it is fine. Okay, I don't mind it. See to it that you are going to follow the long division method. Very important step here, because once it is not there in the rational function or the rational fraction method, so once the long division method forms a major thing to get to your final inverse Z transform. Okay, so what do I need to do here is I need to take the inverse Z transform of this function by partial fraction method. Okay, I'll write it as PF method, which means that it is by partial fraction method. So if you take the Z transform of these functions, it is a standard one. We all know that. Okay, so we all know that what it means. Fine. So if we take the Z transform of this function, it is quite easy for us to find out the Z transform by partial fraction method by the third term over here. So if you find this as a Z transform and this one as the Z transform, it is quite easy. Okay, so it is quite easy for everyone to find out its inverse Z transform of it. And next one, this needs to be performed by partial fraction method. So let us go in detail in finding out the partial fraction method of it. Fine. So I think I have, yeah. So I need to find out by partial fraction method, by partial fraction method, by partial fraction method. Okay, so what do I need to do? I need to have this function here, 1.4375z minus 0.09375 divided by z squared minus 0.125. Okay, so this is what I need to do. So I can further resolve it to make it quite simple for me to solve this. Minus 0.09375 divided by, so what we had here, so z minus, which is the one, that is z minus 1 by 2, exactly, that is z minus 1 by 4. Okay, now it is quite easy for you to solve this by partial fraction method. I don't have to go in detail now. So let me go quickly. 1.4375z minus, okay, 0.09375, okay, divided by z minus 1 by 2 into z minus 1 by 4. Okay, so let me resolve it into partial fraction method now. I have a divided by z minus 1 by 2 plus b divided by z minus 1 by 4. Okay, this is what I need to do now. I have resolved it into partial fraction method. Let me write here using partial fraction method. I hope it is visible and you are able to hear me properly. Let me go ahead quickly. Yeah. So next, what do I need to do? I need to find out what is the constants a and b. So let me find out the constant a first, and let me proceed to constant b later on. Okay, so I have this function here as a. How you are going to find out a? 1.4375 z minus 0.0 z minus 1 by 4. So once you give this function as 0, you will be able to find out a. Okay, at z equals 1 by 2. Okay, at z equals 1 by 2. So can you quickly tell me what is a? Can anyone in the class tell me quickly what is a? Yeah, I'll give a minute time.
2.5.
Yes, what is A? A is
2.5.
very good. It's the right answer. What is B? B, I'll tell you, once you have to find out B, Z minus 1 by 4 should be equated to 0. So what would be the value of Z when you want to find out B? That would be 1 by 4 minus 1 by 2, and Z value here should be 1 by 4 here. Okay? Yes.
Minus 1.0625.
Minus 1.06 minus 1.06, sorry, come again.
25.
25. Okay, that's nice. So we have got the values of A and B quickly. Okay, so now can you substitute it back? Can you substitute it back and tell me how we are going to resolve it into partial fractions? 2.5. Okay, so this value A here is 2.5, and the value of B here is minus 1.0625. Yeah, exactly. So now what I will be able to do here is I have got the value of A and B. So quickly I can substitute it back, and I can get x of z by z. Okay, so what is x of z divided by z? That would be equal to x of z by z, that would be equal to, yeah, you can tell me
0.5.
what would, yeah, so that would be, I need to take the expressions what I have there, 3 by 4, I think it is 0.75. Yes, so this function what we resolved over the partial fraction method has to be replaced here. So that is 2.5 divided by z minus 1 by 2. Okay, the next one minus, okay, 1.0625 divided by z minus 1 by 4 here. Okay, so let me quickly multiply this z over here. Z squared plus 3 by 4 z plus 2.5, that's multiplied with z into z minus 1 by 2 minus 1.0625 z divided by z minus 1 by 4. Okay, so now can you let me know what would be the inverse z transform? So I need to take the inverse z transform of this. So what would be the thing that it's dependent on here? Yes, each and every expression, you are aware of the property of linearity. Okay, you can tell me what would be x of n. Yes, come on. You can go ahead and let me know what is x of n. And you have to keep in mind that the ROC that I have mentioned over here is 1 by 2 less than mod z less than infinity. So mod z would be less than infinity. Fine. Okay. Now I can take it as this way, mod z less than infinity. Next, what is the other way? Mod z, okay, 1 by 2 less than mod z. So mod z is greater than 1 by 2. Okay, so yes, can you let me know? Inverse z transforms. Will you have a negative time sequence here? Will you have a negative time sequence? I repeat.
No,
Will
sir.
you? Yeah.
Pause.
Why? Will you have it?
No,
No.
sir.
Yeah. Why?
The poles are half and 1 by 4, so they have asked for greater than 1 by 2, so it will not
Exactly.
be.
So 1 by 4 will be 0.25. Okay, 1 by 2 is 0.5 here, right? So once I sketch the ROC, I'll be having the poles at 1 by 4 over here and 1 by 2. Okay, so the greater one is 1 by 2. Okay, so I have two poles, that is 1 by 2 and 1 by 4 over here, right? So the ROC, okay, so it is mod z greater than 1 by 2 and it is less than infinity. So what happens here? It is the ROC is greater than 1 by 2. So this is 1 by 2. I have the ROC over here. So at the same time, I have less than infinity, isn't it? So it is moving towards the right, and I can certainly say that it is a positive time sequence. Okay, so it is a positive time sequence, isn't it? So it is a positive time sequence. So what happens in a positive time sequence? Yes, what happens in a positive time sequence? So you are going to get the unit step function over here, right? So from x of z to x of n, if I want to find out, so I need to take the individual inverse z transform of this, and I have to find out what is x of n depending on the ROC that is given over here. Okay. So can you let me know now what would be the inverse z transform of it?
Delta of n plus 2.
Good. Delta of n plus 2. How did you write it as delta of n plus 2? So what is the z transform of delta of n plus 2? So it is z power squared. That is z. Next.
3 by 4. Delta of n plus 1.
Yes, exactly. Delta of n plus 1. Okay. So look at the useful sequences what are given. So this is a constant 3 by 4 and z is there. Inverse of z would be delta of n plus 1. Okay. Now, looking at these two sequences, I have 2.5, 1 by 2 power n u of n. Okay. Next, minus 1.0625, that is 1 by 4 power n u of n. So why in both the cases I have taken it as u of n is, I have come to know that, I did know that it would be the positive time sequence, isn't it? So now I'll just give you a hint. Okay, so what happens if it is 1 by 4? I have changed the ROC for your understanding. So I have changed it from 1 by 2 to 1 by 4. Okay, so mod z, yeah, let me change here also. It is less than infinity. Okay, so now, yeah, can you let me know now? Think and answer. Yeah, these two are the constant terms which are going to be the delta of n plus 2 and 3 by 4 delta of n plus 1. Okay, so what happens to this function over here? So I've highlighted it in a circular manner. So can you let me know what happens there?
Left-handed sequence.
With negative
Exactly.
time sequence.
Yeah, exactly. So you're going to have a negative time sequence there. Okay. So these are the quite important things what you need to remember when it comes to the gate aspects, right? So if you don't know how to analyze it, how to apply whatever the formula that you have known at that point of time, it would be quite difficult and a tedious process. It takes, like, you have to solve till the point there. Okay, so there are many such shortcuts which are there. I want you to like figure out on your own. So what happens if I change the ROC? So can you let me know what happens if this is the ROC? Can you let me know what happens if this is the ROC? This one. I have written it in a circle, like highlighted it as circular, and I have written it as ROC. Okay, so what happens if it is the ROC over there?
Annular region.
Wonderful, very good answer. Yes, so that will form an annular region. So mod z would be less than 1 by 2, and mod z, okay, I've told you like 1 by 4 is less than mod z. Definitely mod z would be greater than 1 by 4. So this one here will form the positive time sequence. Okay, this one will form the positive time sequence, and this one over here will form a negative time sequence for the given ROC. Okay, so the problem that we had solved, this is the final answer. What we have as x of n, that would be equal to delta of n plus 2 plus 3 by 4 delta of n plus 1 plus 2.5 times 1 by 2 power n u of n minus 1.0625 into 1 by 4 power n u of n. So please be very clear about how we are going to write the sequence, and this is the final answer that we get for the given ROC, that is 1 by 2 over here, and that is less than mod z, less than infinity. Okay, so let me quickly sketch the ROC for it. Okay, so this is 1 by 2, sorry, this is 1 by 4 over here, this is 1 by 2, and the circular region, let me draw it, taking 1 by 2 as the radius. I have drawn a circle, and this is the entire z plane there. So this is imaginary part of the complex number there. Okay, so real part and the imaginary part forms here, and you have 1 by 2 and 1 by 4 both as the poles of the given complex number, right? So now the ROC would be here. Fine. So both the sequences will form the right-handed positive time sequence, and this is how you can sketch the ROC. Okay, so we will stop the class here, and in the next class we will be covering regarding the unilateral Z transform and few more problems that we are going to discuss. Okay, so thank you everyone.